Good morning, everyone. So next I will give a topic, the practice on vehicle networking in financial industry. That is our practice in the insurance field. It's also a kind of application in the China Mobile's big data system. So first, let me introduce something about China Mobile. China Mobile was founded in the April 20, 2000 years. Here's a mobile communication operating based on the GSM, TDS, CDMA, and TD-LTE standing networks. China Mobile is the largest telecom operators in the world by customer base and network size. The company's operating income was $150.7 billion, and an increase of the 4.5% over the same period last year. On the user side, the number of the mobile phone customers reached 887 million, a net increase of the 35 million household in the end of 2017. The total number of fourth-generation base stations reached 1.87 million, covering 99% of the population in China. So we are really the largest telecom operators in the world. The number of the smart connection in the Internet of Things, IoT, has increased by 126 million, reaches 229 million. So the IoT market is really huge in China. This topic is an example on the IoT. Some introduction about myself and my college. This project is performed by my college and I. My name is Duan Yunfeng, postdoctor in the Peking University. I'm chief designer and founder of the big system in the China Mobile. We create the data warehouse from 2001, and from 2010 we do some research on Hadoop. That is the history in the China Mobile. So I have the 17 years experience in data warehouse and big data. Presided over the design and the construction of the data warehouse system in the China Mobile, and now become the largest big data system in the world's telecom industry. The capacity is more than 500 PB, so it's too large. And also I create training and create the China Mobile's big data technical teams. Now it's more than 400 persons. And this is my college. His name is Li Shaonian. He's also a PhD. He's an expert in the China Mobile. For some reason, he can't come here, so that's me to give an introduction of this project. These are some books I wrote in the past 10 years. These two books is focused on the data warehouse. It was written in 2005. And these two books was written in 2015, focused on the big data. In this book, I first have the term big analysis. And in this book, I use some source of the internet company to the big data. And this is some data mining applications that we have in the China Mobile. We have more than 60 data mining model all around China. And that is the unified data model application. And also we have some personal data model application too in different provinces. Altogether, it will be more than 1,000. So this is some different method, algorithm and method. And this is some application model. So we can see that the traffic forecast model and also some call customer of networks early morning model and so on. So this, the data mining application now is applied in every field in the China Mobile. This is just some list of this application. And now in the China Mobile, we also do some research on the AI. And we do some research works more than 1 year. And we found that the AI is very useful. This is the architecture of the big data system in the China Mobile. We have the big data system, different big data system in the different province. And they collect different data from the China Mobile. In the China Mobile, we have billing system data and also operating data. Operating means the network, operating network, the network from the network, and also some management support system, MES, some system like this, and also some external data. In the China Mobile, the IT system is more than 2,000. The number of the different IT systems. So it's really a huge work to collect all the data from different items. This is the headquarters in Beijing. We will collect data from different provinces. The province will upload their data to the headquarters. And the headquarters will have some applications for the users, for the different users. Some different field, traffic, the policeman, and also tourism, health, different field. So in the China Mobile, this is the architecture. We have 2 layers. So we call this logically integrated, but physically distributed. That is a theory in the China Mobile. And this is some big data system in China Mobile. We can show that the nodes is more than 70,000 x86 machine in all of the China in the China Mobile, and 15 of this is for Hadoop. The other 2,000 is for MPP. Totally of 160 small mini computers in the 31 province. Because in the China Mobile, we have still some data warehouse platform and also some MPP platform, not only the Hadoop. The system capacity is more than 500 PB. This is some distribute of the existing Hadoop devices. We can show that the many is on the Hive, and the second one is Spark. Also, we have some Kafka and also HBase and others. So that is some for some Hadoop devices. And also, this is the usage of the big data in the system in the China Mobile. The number of the daily active users of the system is about 27,000. The number of the click per day is about 360,000 times. A total of about 81,000 users. Almost 30% of the employee in the China Mobile can use the big data system in China Mobile. And also some introduction about the technical architecture of the big data system. From this technical architecture, we can see that in the China Mobile, we have different systems, and also we have some data governance functions. This is some data standard management. I wrote different kinds of documents on the data standard. It's more than 150 copies. It's really a huge work. And also some metadata management, and the data quality management, and the data assessment management, and data security management. We do this data quality management and also data security management more than 10 years. So we really have some experience on this field. And this is the data sources, the BSS or SS, just as I have show you. And this is the unified data collection. We have different characters, the stream collection, and also some batch, and also some data from the web. We have a unified data center. This is the stream computing, storage, and computing, and MPP, and also data warehouse. In the China Mobile, the data warehouse will do some traditional analysis. And the MPP is the data mart for data mining at this time. And also the Hadoop is doing more and more computing, and also the applications. This is the open framework, the data openness, and also the resources openness, and the tools openness. China Mobile almost buy most of the data mining tools in the market. So we have some experience on how to use this. And also some application center, the industry, different field applications, and also some platform data products and other products. In China Mobile, we divided the users into different actors. So because of the different users, they need different kinds of application. So that is why we should divide the users. Now we go back to the topic of this project. First is the background and the platform introduction, and also the data collection of the ViewFS network. The third is the risk assessment algorithm. The last part is a real application case to share with. This is the background. In China, the vehicle is more and more. So it's very important to connect the different the vehicle. So this is some figures we can show. The vehicle ownership reaches 310 million at the end of 2017. In this year, in the end of this year, maybe 28 million new cars will come to us. So it means really the first huge vehicle market in the world. So the problem is how to connect them, and also to support some service for the vehicle networks. In the vehicle field, the very important market is about the insurance. The income of the car insurance accounts for more than 70% of the total property insurance revenue. And in the 2017, it's over $100 billion. So it's really a huge market. However, 40 of the 53 insurance companies suffered a loss in the vehicle insurance business through 2017. The problem is focused on the high channel cost and also the loss ratio. The channel means that someone sell the insurance. In China, mainly it's the car store. When he sell the car to the customer, he also sell the insurance to the customer. So we call the channel. And the loss cost is 50%, means more than $50 billion. It's a very huge market. So this project is focused on the insurance market of these cars, of these vehicles. The financial institution has a strong demand for reducing the cost of receiving customer and paying the cost. But at this time, the insurance company is very lack of understanding of the users because no way to get the data from the drivers. This is some introduction of the platform. The China Mobile, we do cooperate with the insurance company. First, we should get some information from the vehicle, and also we do some application. This kind of application is focused on the trunk transport. In China, 80% of the trunk, the driver of the trunk, they loan from the bank. And also for the bank, they do suffer about the insurance on these trunks. In USA, or the driver of the trunk will, when they drive maybe 4 hours, they will have a rest for 20 minutes. But in China, most of the drivers in the trunk is two drivers. One is driving, the other is sleeping. And if this one is sleepy, he will let the other to drive the cars. So for the insurance company, it thinks this maybe so dangerous. So how can we do some things or applications on this condition to make sure that the insurance can get the condition of the drivers in the trunk? So carry out the big data analysis and the different insurance service on account of the user driving behavior, travel habit, driving environments. That is very important for the insurance. All these different kinds of data can be collected by the vehicle networks. So in the China Mobile, we can provide a driving behavior analysis service and also continuously supervise and improve driving behavior and provide a real-time certified monitoring on the motorcade for insurance companies. Monitoring the accident situation after the customer is out of danger and reconstruct the accident so as to prevent fraud accurately. That is the goal of this project, and also is the main content for this project. So from this picture, we can see that this is the insurance company, and we have some financial service platform, and we can support. We can give some accident reconstruction. We can give some construction, accident reconstruction, and also some driving habit, and also some driving environment and driving habit and also some real-time monitoring. So we can have some details to monitor the habit of the driver. So the second part is about the data collection of the vehicle network. Now at this time, with the some special devices, we can collect the vehicle's status. These devices, we can divide it into we call the pre-installed by the automobile manufacturers. It means before the car was for the customers, it will be some sensor devices will installed in the vehicle in the factory. So we call pre-installed market. The other is installed by the external manufacturer. After the car, if the car in the factory it doesn't have such kind of sensors, maybe the other factories can support some sensor. So we call this as the installed by the external manufacturers. Based on the requirement of the platform and the existing condition, the platform currently collect data mainly through the following means. This is some we can see. First, we collect the data of vehicle operation data and driving behavior through the rear-mounted. Rear-mounted means the external manufacturer. The rear-mounted, we call it OBD. OBD equipment. OBD equipment, in most of the cars, they have such kind of bus. It's a standard interface. And also the mobile gyroscope. The gyroscope mainly on the cell phone. All of the cell phone at this time have the gyroscope. So this is a very sensitive sensor, so we can find the status of the driver. The second is to collect the vehicle's trajectory through GPS and signals, and also collect the driver's status data through the driver's figure monitoring system, and also collect the vehicle driving environment through the ADAS, Advanced Driver Assistance System. Yeah. So that is the way that we, in this project, we can collect the data from the vehicle network. This is some method or the algorithm that we can recognize the driving behavior through the OBD. This is some data information such as the vehicle speed and the driving time, or the other data to start time, end time, duration, maximum acceleration value, and the average acceleration value of the transformation analysis. When the acceleration reaches the preset maximum acceleration threshold, the acceleration process began to calculate. Only when the acceleration time exceeds a certain value, it is a rapid accelerate event. So we have different status. This is the behavior. This is the rapid acceleration and also rapid deceleration, and also some slam the brakes on. So this is some status that how we define it. This is the acceleration, this is duration, this is speed. This is some rows. This rows is from the insurance company. They can give us the standing. And also this is the algorithm we can see. For example, in this figure, the red dotted line in the above figure indicated that the acceleration decision threshold is 3 meters per second. And the black line shows the driver's acceleration in the course of the moving of the vehicle. The arrow of the purple dot indicates that the variable behavior in the time section is judged to an acceleration. The acceleration of the vehicle exceeds the decision threshold, and the duration is 2.5 seconds, which satisfies the critical term of the acceleration. That is how we find its acceleration, and also this is the sign of how can we find its quick deceleration. In this figure, we can see that the 40 figure so the accepted map of the quick deceleration behavior. And the purple dot arrow indicates that the vehicle speed behavior in this period is a quick deceleration behavior. And the black real line indicates that the acceleration of the driver in the course of the moving of the vehicle. So this figure, the duration is 1.5 seconds. So it is judged to be brakes. So this is the different things that we can show. So this is the acceleration. This is the deceleration. So we can, from this data, we can find the difference. So that is the method. And also some sharp turn. Sharp turn. How can we recognize such kinds of driving behavior? This is the blue dot line indicates the angular vehicle threshold of the sharp turn behavior. The black real line indicates the curve of the motion angular velocity, and the red dotted line represents a sudden turn. This is the red one. So it means the sudden turn. We can see that this is the direction angle. This is the angular velocity. So we can, from this curves, we can see that is a sharp turn. So from this data, we can see the different behavior of the drivers or of the vehicles. So that is the method of this project. And also, this is the indication of the drastic driving behavior. In this, just as we have shown before, that this is the rapid acceleration, this is the rapid deceleration, and also this is some brake. With this method, we can see the status of the vehicles, whether it is dangerous or not. So, and this is some devices that we can identify the driver environment, monitoring and analysis of the driver. This is from the driver's facial features. At this time, we didn't do this analysis, but in the future with the AI, we can have a camera and for the drivers, whether he's sleepy or not, whether he drink the water or smoke. with this picture analysis, we can find the behavior of the driver. So that will be very interesting. That will be very interesting. And also identify the location of the external environment. The environment means some lane keeping and lane change, or some car distance, or some light intensity. And also we can, from these things, we can see whether the driver answer a phone call, operate air conditioning, and drink water, smoke, and also. And also we will use some external data. This is from the some weather data, and also some traffic police data, and also some GIS data. The weather including the visibility of the day, wet condition on the ground, and wind, power, etc. This will have a direct impact on driving behavior. So this is some external data we should collect. So the third part is mainly focused on the risk assessment algorithm. This is the algorithm we used, the AHP, Analysis Heresy Process Algorithm. And also we use the EW-AHP and also the AEW-AHP. So the algorithm is not very difficult, but this is some theory we can see that is some method of this algorithm. It is in this project we use this algorithm. This is some step 1, step 2. This is the familiar how we calculate the different weights of the items. And this is the end. This is the result that the result assessment model. We can analyze more than 4,000 driver behavior. And with the insurance company, we can find the different ways. For example, this is the result. The driving behavior will have the weights more than 70%. And each sub-items, we can say acceleration frequency is this weights. And also deceleration frequency is also these weights. So this is behavior, this is environment, and this is some habits, and also some vehicle properties and the driving attributes. So this is the different weights of this behavior, and this is some sub weights for this sub behavior. So that is very interesting. And in the end, we can show us application case. It's a real case in the China Mobile. This is an example that we can, with the algorithm, we can calculate a score of different fields. This is the behavior, driving behavior, and also driving environment, and the driver, and also some habit. So this is a real, we see a real chunk, a real chunk. So we can see the scores he get. This is some the driver behavior, and this is some about the driver, and this is about his vehicle, and also some vehicle habit, driving habit. We use the installing OBD and also some mobile phone software, app. From these two ways, we can collect the data of the vehicle. So the customer is 4,243 and build a car network financial risk assurance model. And this is the result. It's very interesting. We can see that this is the average score. And also this person, 79, the score is very low. And also they have some driver, the score is very high. So there is 40% with a score lower than 6 point. One of the drivers' driving habit is very bad, this one. And there are 6% with a score higher than 90 points. Most risk assurance are between 70 to 40 million scores. So from this figure, we can say this person is very dangerous. And this is the data that show this. The blue ones say the car accident times, more than 4. This is the 79, number 79, the biggest car accident. So it is very interesting that he's still alive. So we can see that the driving habit is very important for us. And also we can say this is the 5 city in the province, in the Hunan province. And we can see with that algorithm, we can find that this city is very dangerous for the insurance company. So maybe the insurance company will like this city, doesn't like this city. So and this is the vehicle risk index for cluster analysis. We also have the different scores. This the scores more than, if the scores more than 90, it will means high risk customers. So the insurance company maybe cannot give them some research, some insurance. And this is some good customers, the primary customers. This is some we say the transferable risk. You should give them more control. And that is the result of the score. And this is the example too. That at different times we can see the drivers. This is the true driver. A driver's status. It means he's not concentrate with the driving. This time. So monitor driver's real-time status and timely detect driver's wreck and some other conditions. And this is the result of the vehicle insurance fraud detector result. This is in the province, Hunan province. It's one of the provinces in China Mobile. Here, claim means someone disagree with disagree with you. So altogether, they have 2,000, and among this, 800 was about the auto insurance claims. So we can see that the vehicle claims is more. So in 34 vehicle insurance, we can find the fraud case. There are 6 cases based on the drunk driving, and the owner tried to cheat in various ways. That is, for example, A driver, he drank, he had the accident, and he tried to say not he is driving, he will let the other, maybe the B driver, to say that the B driver drive the cars. But with the vehicle networks, we can see that the A driver and the B driver is in different place. So we can say that only A driver was driving this car. So he cannot say that he is not driving the car. this is the true example for us. So, and also for the insurance company, it is very important. Because if the driver drank, so the insurance company will pay nothing. Will pay nothing. So that is very important. This is an example. So that's thank you for your attention.